Yeah, so welcome everyone. My name is Finbar Duncan. Thank you for joining the first of our series of webinars. First of all, I'd like to just quickly introduce Pippa Chapman, who will be giving a bit of an introduction to today's session.
Good morning, everybody. I want to say welcome and thank you for joining. As Finn said, this is the first of our webinars related to the Freshwater Quality Programme. These webinars are going to run monthly over the coming year. And for those of you that don't know very much about the Freshwater Quality Programme, the next slide shows you some of the objectives of that programme. And it's really the aim of this programme. It's been funded by NERC and DEFRA to the value of £9 million. The programme will run for 4 years. It started this year. And the aim of these webinars is to bring together researchers, practitioners and policymakers to ensure the research that we're carrying out in this programme leads to a step change in our understanding of freshwater quality processes, interactions and risks, including resilience to land management and climate change, and really to ensure that the research we're carrying out within this programme supports policy and practice in this area. And so within this project at Leeds, we're a small team that are overseeing the programme, but the main research is going to be carried out within 5 research projects. And this slide really gives you a little overview of the 5 projects, their titles, the person that's leading the project and the institutions that are involved in each project. And via these webinars, we'll be hearing a little bit more about the progress that these projects are making. And that will be in next year, from January onwards. We'll be hearing from each of these projects. But prior to that, we've invited stakeholders that are interested in the policy, the practice of freshwaters, to give their perspective on the issues, the potential solutions around freshwater quality. And they're from both within the UK, but also abroad as well. So that's the lineup, and we'll hear a little bit more about that at the end. Over the next few months is really looking at different perspectives. And then in the new year, we'll be hearing from these projects. And if you want to know a little bit more about the programme, if this is the first time you've heard about it, there's different ways you can engage. We have an email address, freshwater@leeds.ac.uk. There's a website where you can find out a bit more about the individual projects, and we're on social media. But today I'm going to hand over to Ed Latter from DEFRA, who's going to talk about the development of the chemical strategy before I hand over you to Ed. Thank you.
Thanks, Pippa. And just a second while I get my slides up. Here we go. And just share these. Okay, is that now? Okay, right, there we go. I hope that's presenting for everyone. Yeah, good morning, everyone. Thanks for the invite today to present. So my name is Ed Latter. I work in DEFRA in the Chemicals, Pesticides and Hazardous Waste team. So my plan today is just to talk a bit about some of the work we're doing in DEFRA on chemicals, including our work towards delivering a chemical strategy, and we'll highlight and focus a bit on some of the issues where that interacts with water quality. But first, in terms of, I'll start by setting the context really in which we do our chemicals work, and that's the DEFRA's Environmental Improvement Plan that was published earlier this year. So the background to this is 5 years ago, the 25-year Environment Plan was set out government's work and government's vision to help natural world regain and retain good health. We said in the Environment Act that the plan would be refreshed every 5 years, and the Environmental Improvement Plan represents the first such review of this. So this really, to achieve the vision that the 25-year Environment Plan set, we set 10 goals. Those 10 goals have been stuck to, but there's quite a focus in here in terms of describing the apex goal of thriving plants and wildlife. So this really is about our plan to continue to deliver these targets and to meet and restore nature. And to restore nature, we need to improve the quality of our environment. So the work I'm going to talk about fits mostly into goal 4. So managing exposure to chemicals and pesticides, I'll touch briefly now on goal 3 as well, obviously clean and plentiful water. There's a chapter on that as well. So as we all know, water is essential for human health, biodiversity, and the economy. We all need access to safe, reliable, resilient supply of clean and plentiful water for our homes, businesses, and for leisure. And if you're interested, please do have a look at the Plan for Water, which was published earlier this year. So that provides a lot more detail on a variety of water quality issues. There's just the infographic on the screen here to note a couple of them from the Environment Improvement Plan, but the Plan for Water is really where the detail of that is. But I'm going to focus more on goal 4, which is managing exposure to chemicals and pesticides. I'll talk mostly about chemicals, just touch on pesticides very briefly. But really, the aim of this goal is we will make sure that chemicals are safely used and managed, and that levels of harmful chemicals entering the environment, including through agriculture, are significantly reduced. You'll see on the infographic here, there's a number of things we've highlighted. So tackling chemical pollution at source, but also targeting. I think the important one in terms of the research needs and how it interacts with our evidence is around targeting the greatest risks with our monitoring program to understand chemical pathways and exposure in the environment. And just seeing the kind of the aims that PIPA put up around the research program, hopefully you can already see that, how continuing to understand and develop our understanding of chemicals and how they get into the environment and how they interact with the environment is a key thing on which we need as policymakers to make sure that our policies and regulation is effective. I think the other thing I'd say is, we recognize that chemicals are vital to society and help us achieve many goals. So chemicals are found in almost everything we buy and use, with more than 95% of all manufactured products in the UK containing inputs from the chemical sector. So given the importance of the chemicals and as benefit society, we also want to promote a thriving UK chemical sector. But at the same time, chemicals can cause harm to human health and the environment. So we need to ensure the way they are manufactured, used, managed, and disposed of is safe for communities and the environment. So our focus for delivering progress on this is structured into 3 goals. So as I've already touched on, ensure chemicals are safely used and managed. I'll talk more about this. Minimize the risks of impacts and pesticide. I won't really talk about this. This is kind of going to be covered more in the UK National Action Plan for Sustainable Use of Pesticides. And also on the third one, harness UK expertise internationally to improve global chemicals management. I think this is important for kind of those working in the research area and also thinking about the global context of chemicals management. It's not just a UK problem, but it's also an international problem. And I'll touch on that as well later. So one of the things that we committed to in the Environmental Improvement Plan was to develop and publish a chemical strategy in 2023. This will really set and frame the work we are doing. Much of our chemicals regulation and policy used to come from when we were an EU member state as part of the EU, but now as an independent nation, we can set our own course of travel and direction. And that's really one of the aims of the chemical strategy. So the aim is for it to be a cross-government strategy, being led by DEFRA, but working across government. We want it to be UK-wide, subject to agreement with devolved administrations, but working with Scottish, Welsh, and Northern Ireland government is part of that. Our current working plan is to set a 2040 vision. So, not in the short term, but not sort of too far in the future. But we think kind of 2040 vision gives a good time for a strategy to be delivered. In terms of what it will do, it will frame the work we're doing across chemicals and set the direction of travel, put us on a path for improved chemicals management, and set our priorities and principles for taking regulatory action. The way we've kind of structured our thinking and development has so far been around 4 main themes. So priority chemical issues and emerging risks, regulation, managing chemicals throughout their life cycle, and international. And I'll just touch a bit on each of these with a bit more focus on the first one. So when we say priority chemical issues and emerging risks, 3 of the main areas that we're looking at here are endocrine disrupting chemicals, PFAS, and also thinking about the combination effects that different chemicals have on the environment. Firstly, on EDCs. So we know that there's endocrine disrupting chemicals are grouped because they disrupt the normal functioning of the endocrine system. They are used, the sort of chemicals we're talking about here are fairly widely used in things such as plastic additives. So phthalates and bisphenol A are probably some of the better known examples, but it's potentially quite a big group of chemicals. Some of the lists around suspected or potential endocrine active substances is quite long. So in order to effectively prioritize, we need to consider the evidence available and draw on a range of expertise. We need to improve testing and identification of EDCs to inform regulatory decisions and policy development. So although this has been an issue around for a number of years, there's still a significant uncertainty in the science and in some of the understanding the impact that EDCs have on wildlife and on the ecosystems is something that we want to continue to improve. But also, where there are uncertainties, the precautionary principle, which is something else that we look to kind of adhere to, the uncertainties and gaps in evidence shouldn't prevent action. So we also need to consider how we address or analyze uncertainties to apply the precautionary principle, particularly when we think about vulnerable groups or multi-generational effects. The irreversibility of effects of EDCs is important. I think it's worth saying as well that we're building on the current regulation. Action can and has been taken through our regulatory framework to address risks from EDCs. Tributyl tin is probably one of the best known sort of examples for the impact it had on mollusk populations, but has now been banned. So we do already have kind of the regulatory tools, but we want to improve how evidence and science kind of can feed into them. One of the other big topics is around PFAS. So PFAS is a very large group of substances used very widely across many sectors of industry and society. Although it's a large group, there has been focus a bit more historically on some of the individual ones. So we have already banned or highly restricted specific PFAS such as PFOS and PFOA. But there's growing recognition of the wider presence of PFAS in the environment. And also one of the common features is around the very high persistence. So there may be gaps in some of the hazard data of that wider group of PFAS, but we know that high persistence is a fairly common theme. So within that common theme, also understanding the diversity of the different group of chemicals, trying to get that how that informs our policy position. So as part of informing our policy position as well, we work across different stakeholders. This isn't just about government and central government departments sort of working on this, but we very much listen to representatives from across different groups of stakeholders. So NGOs, industry and academia and government, all important to feed into that policy process. One of the big things that was done earlier this year, so the Health and Safety Executive, one of our regulators for chemicals, published an analysis of PFAS risks in GB with recommendations. This was working very closely with the Environment Agency. So as part of the program, this was kind of a big piece of analysis which took a fair amount of work. One of the recommendations of that was to use UK REACH restrictions. So one thing we recognise is needing to stop the flow of PFAS getting into the environment. And the recommendation there was actually kind of split the restrictions down into 3 different parts. One, starting with firefighting foams, then thinking more about more scoping work that's going to need to be done on wide dispersive uses and consumer articles. So our DEFRA ministers have agreed to this recommendation, and we will be taking forward work, our regulators working towards those restrictions. There's also some other recommendations in there. So I think one thing on PFAS is it's going to need a mix of different policy measures to tackle the risks. We need the understanding of the risk, but part of the RMOA also uses or recommends targeted use of UK REACH authorization, so a different regulatory tool for some specific industry uses. And there will need to be continued collaborative work to bring together PFAS more strategically. In particular, there were some things in the RMOA that were out of scope, so things around discontinued uses or legacy uses. So that's something where the chemical strategy will hopefully build on the RMOA and bring together collaborative work and strategic work on PFAS. The last priority issue I want to touch on is combination effects and unintentional mixtures. The research projects that Pip showed at the start, I know there's one on mixtures there. So this is again something that we've recognised as a priority issue. The basis for this from a policy perspective is really, chemical risk assessments are generally performed on single substances. There's uncertainties around the potential additional toxicity that might arise when various chemicals from different sources mix together. And this is not formulated mixtures. These are unintentional mixtures, typically from a variety of sources. People and wildlife can be exposed to different combinations, both in space and in time as well. So it's a very complex issue. Building on some of the science research, last year the Environment Agency and the UK Health Security Agency reviewed the evidence and published a report on how we may address this issue under UK REACH. One of the recommendations there, or one of the main recommendations, was to use a mixture assessment factor. So we're looking at that recommendation. Our policy work is continuing, and we'll set out more details in the chemical strategy. But I think we also recognise, one of the other things that came out of the report was there's still a lot more research that's needed to really fully inform what we do. And there's a question about what we do in a regulatory space, but we recognise even, what we do there will still need to be a continued research programme and to help us further our understanding. I'll quickly touch on the other issues as well. So on sort of monitoring as well. I think that's a key thing, understanding what we have in the environment. We need to address emerging unknown threats, so enhancing our monitoring, enhancing our horizon scanning, building a strong evidence base to support identification and prevention of emerging issues is key. As part of this, we're now using a prioritization and early warning system to inform decision-making and regulation, which brings me nicely onto regulation. So the chemical strategy will set out an approach to regulation that is risk-based while also adhering to the environmental principles policy statement, which is enshrined in the Environment Act. I mentioned the precautionary principle, but there's 5 in total of the environmental principles. We'll set out how we continue to use UK REACH. UK REACH is a key part of our chemicals regulatory framework. And this includes things around the alternative transition model, which is being developed because of the transitional cost to industry. We also need to think ahead about how our regulation can make the best use of science and technological advances. So part of the regulation team will also think about how we can integrate new test methods and new approach methodologies to increase the efficiency of chemicals hazard information. Another area is supporting a circular economy approach throughout the life cycle of chemicals. So we recognise chemicals emissions into the environment can happen at various different stages of the life cycle through manufacture, use, and then into the waste stream or recycling. So looking at that entire life cycle is important for managing risks to the environment. We also need to harness UK expertise internationally, as I've mentioned. So this is important in a couple of different ways. So the UK is committed to international action on chemicals management and continuing to take a leadership role using our scientific and technical expertise, as we are currently doing, leading a nomination list, for example, under the Stockholm Convention of medium chain chlorinated paraffin. So that's just an example where the UK is taking leadership internationally. We're also committed to being involved in international collaborative science programs, such as one of the main ones for chemicals risk assessment is EU PARC, so the Partnership on Risk Assessment of Chemicals, a big Horizon Europe partnership, and we're involved in that. So there's a strong kind of international science community there. So that's a bit of a whistle-stop tour of all the themes of chemicals management. As I'm sure you'll appreciate, there's lots of detail within each of those themes, but hopefully that gives you an overview of where we're coming from a central policy perspective, the range of themes we're looking at, how we're setting out the strategy. We're still aiming for publication in 2023. But I think kind of just thinking about that, this is not the end of the journey. This is setting a direction and start of a process really of continued kind of chemicals management will set us on a path to that, but we will still need continued engagement with stakeholders. We still need kind of active research in this area to ensure that our policies continue to be informed by the best available science and evidence. So I'll pause there, and I think taking Q&A, so I'll stop.
So thanks very much indeed for having me along today. Really happy and excited to be part of this, really. I think it's fair to say at SEPA we're excited about the freshwater quality programme. We've been involved from the start, really. I think we can see some really great benefits from it. But I think this initiative's really important as well to make sure that the outputs are as influential as they can be, really, and as helpful for us, of course, in SEPA as well. So I'll aim today to outline SEPA's role a little bit for those of you who might not be familiar with this, and the main things we're doing to protect and improve water quality. I'll set some context, and then I'll aim to cover some of the main research gaps and questions that we have in delivering this. It's fair to say SEPA at the moment is in quite an interesting stage. Like all organisations, I guess we're recovering from COVID still, but we also suffered a very significant cyber attack at the same time as COVID was happening, which really affected our ability to work, really. It affected our ability to access data and all of our systems. So as we rebuild from that, we are starting now to look at our R&D programme. We haven't had a chance to review it for the last few years because of the rebuilding process we're going through, but we will be doing that in the coming months. So I would look out for that. I'm very happy to report back as this progresses, and I think we'll be speaking to quite a few people involved in the freshwater quality programme as part of that process. Okay, so hopefully that's moved on. Yeah. So in terms of SEPA and what we do, we're the primary environmental regulator in Scotland. So I guess analogous in many ways to the Environment Agency down south. So we're an agency of Scottish Government rather than part of the government per se. And we're lucky, I think, in that we have a very clear statutory purpose to protect and improve the environment in ways that, as far as possible, also create health and well-being benefits and sustainable economic growth. So our purpose really does put the environment at the heart of Scottish society. And it's probably, I think, most important to stress that the most important twin bits of policy at the moment that the Scottish Government's pursuing are related to climate change through the Climate Change Plan and also the Scottish Biodiversity Strategy. So these are really at the heart of the work that we do, and these are the key bits of Scottish Government policy that we work towards. And I'll emphasise that as I go through our main bits of work in the presentation. In terms of regulating water quality and improving water quality and measuring water quality in Scotland, river basin planning remains really the main way in which we do this in Scotland. That's the most important mechanism. Our latest plan was produced in 2021, covers a 6-year period up to 2027. And we organised our work through river basin planning to 4 main themes. Generally, it's fair to say the majority of our water bodies are at good status, and we've seen some improvement, fairly modest, but still improvement since 2015. And we've got some fairly significant ambitions to improve that further by 2027. You can see in this slide the main actions that we've got in the River Basin Plan, and you can see right at the top we've got rural diffuse pollution. That's the biggest area in terms of action to be taken by 2027 for water quality. Also, some significant number of actions associated with wastewater discharges as well. I think it's also important to point out, and I won't say much more about it for the rest of the slide, but there's a lot in there as well about addressing barriers to fish migration and physical condition. So those are important priorities for us and for the Scottish Government. I think the other key point to make about our approach to river basin planning is when we've been thinking about our programme of measures, the latest plan really emphasises the links to wider objectives, particularly those associated with climate change mitigation and resilience, and also biodiversity conservation. We recognise if we're going to achieve these benefits, we really have to do it in ways which reflect this broader context. Ultimately, these problems are all manifestations of the same systemic issues. So a lot of our work is organised in that kind of context. So moving on, in terms of thinking about some of the challenges and opportunities we've got in these different areas. The first one I'd like to talk about is wastewater challenges and opportunities. So in the Third River Basin Plan, we've identified 40 wastewater treatment works which need action. And the plan of work there is relatively well defined and prioritised. But CSOs as well, of course, have risen up the agenda in Scotland as they have across the rest of the UK. And they were identified as a priority or a requirement for River Basin Plan 3 as well. And we're dealing with these through the Improving Urban Waters route map, which is part of the measures programme that we've put together. This sets out actions required at the highest priority CSOs, the ones which are linked to river basin management planning objectives. But it also commits to dramatically increase monitoring and reporting of spill rates at CSOs, at a prioritised network of CSOs. There's over 1,000 of those. This includes ones which have received environmental complaints, but also ones where we've got evidence of sewage debris and evidence of ecological damage. So we've got several questions, I think, in this area which would benefit from new research. Firstly, we're going to get a lot of new data on CSO spills, the frequency, duration, and we really want to understand what this means for water quality and, crucially, for ecological impact as well. At the present, it's fair to say we don't have very strong evidence of widespread impact of CSOs on ecology. There are relatively few RBMP measures associated with them. And this new data really will, we hope, provide much more context to our existing monitoring and will help us interpret our findings in more detail. The key questions really for us here are, what's the composition of the CSO spills? How does it affect water quality in the receiving waters? How long-lived is the effect and what determines that? And really critically, what's the ecological impact? What effect is it having on ecosystems? We've also got research questions here associated with solutions. We're heavily involved in SEPA in promoting blue-green infrastructure projects in our urban environments. These are really multiple benefits, or they're aimed at addressing multiple benefits. So climate change adaptation and mitigation, particularly helping communities deal with flooding, but also biodiversity benefits and benefits to communities for greater access to green spaces in the cities. So we really, I guess our main questions here, or high-level questions, is how effective are these solutions in addressing water quality issues? What elements in the design are most important? And practically, how can we optimize the designs to make sure we're getting the biggest water quality benefits from these designs? And then how can we incorporate these into some of our own urban restoration projects as well? We've got a big project through our Water Environment Fund of looking at morphological improvements in the urban environment. And we really need to, or we'd really like to know, how can we best design these to address water quality issues as well? I think the other area I'd like to raise here as well is bathing waters. Generally speaking, our beaches are in pretty good state. We have a big program of bathing water classification, and we're finding that things are good and generally improving. But increasingly, of course, we're seeing pressure, increased pressure, expectation and interest from the public in swimming in freshwaters and in rivers. At the moment, we don't have any designated rivers for bathing, but we're under pressure to change that potentially. And we need to know about usage patterns by the public in our rivers. We need to understand better how safe they are for bathing and what are any human health implications of current water quality conditions. I guess our main question following on from that will be what might be needed, if anything, to increase standards and how can this be achieved most effectively. So that's a pretty important priority for us at SEPA. Moving on to the rural side, as I said, this is a major piece of work under our River Basin Management Planning Programme. And our main action here has been our priority catchment work. The map on the right shows the 57 priority catchments that we work in as a high priority. And the programme here is really a series of farm visits and repeated farm visits. Initial visits are to assess compliance with general binding rules. These general binding rules cover a range of activities. They're fairly low-level regulation, but they cover things like buffer strips, fencing livestock from riverbanks, slurry storage, fertilizer application, pesticide use, and so on. So there's quite a number of different general binding rules there. So our initial farm visit assesses compliance, and then we have follow-up revisits, at least one or often two of those, to see how compliance has improved and to check that the farmer is taking necessary action. The main benefit really of the thing that has really shifted our work on through the priority catchment work is these have given us an opportunity to engage directly with farmers. We've had a good opportunity through that to develop relationships, to influence behaviour, to educate farmers, and it gives us a link to additional agri-environmental payment schemes and to explain that to them should they want to go further. It really has changed our relationship a lot with the farming sector, and we're finding that compliance rates have expanded from initially a very low level to much improved compliance with general binding rules. So it's been quite successful. It's an ongoing program, but now we really need to understand what is the impact, what's the actual impact of this increased compliance now on water quality. We want more tools and we want more approaches to be able to quantify that more effectively. But I think it's probably fair to say that we expect that it won't be enough through this approach alone to achieve RBMP objectives. And we're expecting that we will need, and our RBMP, our latest RBMP sets out indeed, additional delivery mechanisms that will need to deal with rural diffuse pollution. And a lot of our effort is going into promoting these approaches, and particularly, as I've been saying, really about ways of dealing with rural diffuse pollution that meet multiple benefits. So we really want to work, and we've got research questions about how do we quantify and predict the impact of these nature-based solutions on water quality. We want to identify also areas of multiple benefits that will provide natural flood management, for example, natural flood management protection and improvement, biodiversity benefits, improvements to morphology, improvements to recreation, but we also want to include water quality as part of that. So the map on the bottom left, for example, shows areas of Scotland where we know our riparian zone needs work, needs protected, and we would really like to work on water quality metrics and in improving our understanding of what this can do to improve water quality, what these methods can do to improve water quality, to build that into the picture. A couple of really important emerging opportunities here are private finance, for example, through the Riverwood scheme, which is a big national project, which is levering private finance. But also there are major opportunities through the CAP reform process as well. This is going to be heavily focused, without a doubt, in Scotland on climate change mitigation and biodiversity benefits, but we really want to make sure that water quality benefits can be included in as much detail as possible. So moving on then to chemicals, a little bit similar to some of the stuff we've heard earlier from DEFRA, really. SEPA has also produced a chemical framework recently, and this really sets out a vision to set out and explain how we really want to see a much more systemic approach to managing chemical risk. We want to understand the whole life cycle of chemical use, and the vision really sets out how we want to eliminate the need for harmful chemicals where possible, minimize the impacts of chemicals where their use is necessary, safely and sustainably use, recycle and dispose of chemicals, and where necessary prevent or remediate any of the environmental impacts from the whole life cycle of chemicals that we see. In terms of research questions specifically here, we're really interested in what are the main sources and pathways of chemicals, what are the risks and threats of new and emerging chemicals, what are the long-term threats of persistent organic pollutants? And in terms of impacts, this is probably the main thing that we would like to emphasize is what are the real-world impacts on ecosystems and human health of the unintentional chemical mixtures that we see in the real world? It's important to know where the chemicals are, of course, but equally or more importantly is what impact are these actually having? We've also got some work streams looking at new and emerging additional effects, particularly antimicrobial resistance, but also plastics and microplastics. And overall, I guess our key question at the heart of all of our chemical framework is how do we best manage and regulate the risks that we're seeing from these chemicals? I've mentioned climate change a lot, of course. This is extremely important. For us, it's a cross-cutting, it has an enormous cross-cutting effect on all aspects of our regulatory work. We're seeing, particularly over the last couple of summers, we've seen really drastically increased drought issues, but also flooding. And our main questions here really are what effect will this have and what effect will future predictions have on pollutant loading, on transport and on concentration. But also how will these new stressors and increasing stressors interact with water quality? And I guess related to this, what role does improving or decreasing water quality have in terms of ecosystem resilience to these future climate change pressures? And again, related to this as well is essentially climate change is really creating a shifting baseline for our assessment programs as well. The reference condition sites that a lot of our standards are based on are changing, and we need to understand what's the correct regulatory and policy response to that. And that's a difficult question, and quite a few research questions, I think, associated with that. So I think the last slide I've got then is thinking about monitoring and assessment. We spoke about this a little bit earlier, but we are in the process, of course, of evolving our monitoring networks. It's a bit of a consistent process, but at the moment, I think we're at quite a key stage with this. We're really asking the question, do our monitoring tools and assessments that we've got at the moment measure the right things? We've done a lot of good work over the last 20 years since the Water Framework Directive came in, but it's quite right to ask the question about what impacts we might be missing. I think also we're pretty good at assessing what's out there and cataloguing, but what we've been less successful at perhaps is in some cases identifying the root cause of the pressures that explain some of the ecological effects that we're seeing, and also particularly in developing solutions. So we need our monitoring networks to gather data to help us deliver these things. At the same time, it's really important to stress that we need to maintain statutory reporting. We have regulatory standards that we regulate against. It's very difficult to shift those. And we need to maintain our comparative data sets as well. So we need to keep both of these things going at once. And certainly anything that can help us in our design of monitoring networks and our evolution of them would be very, very welcome. We are involved in delivering new innovative approaches. We've got a genomic capability in SEPA. We've been doing a lot of wastewater epidemiology, for example, but we're also doing some eDNA assessment of the environment as well. But we need to understand how best to integrate these new innovative approaches within our existing monitoring programs. We're also developing a chemical screening approach. We're involved in work to develop and use sensors and remote sensing as well for a lot of our environmental assessment, as well as new monitoring approaches as well. I think it's fair to say as well, one thing we're going to be looking at in terms of evolving our monitoring networks is better integration between our biological and our chemical monitoring. We're still sometimes working at networks that are somewhat disparate, and that is affecting our ability to interpret the outcomes. And the last thing I would say as well is, although we've got lots of potential for changing monitoring networks and new innovative approaches, what about the value of our existing data sets? We've spent a lot of money and we've got a lot of data out there. There are new ways of looking at that, new ways of interpreting it, and anything that the program can come up with that will help us with that would be very welcome as well. Okay, I think that's it. That's plenty from me. Thank you very much.